In section 11.6, we move on to talking about the surface areas and volumes of spheres. So let's start off with some vocabulary. So first of all, we have a sphere is the set of all points in space equidistant from a given point. The center of the sphere is that point that's equidistant from the surface of the sphere. So the point exactly in the middle of the sphere is going to be called the center of your sphere. The radius is a segment that starts at the center and goes to another point on the sphere. The diameter is going to be twice your radius, and it's going to be a segment that passes through the center, connecting 2 points on the sphere. A great circle. A great circle is created by the intersection of a plane with a sphere. So if you see in this picture here, I've got this plane slicing a sphere. We're going to create a great circle. But the main point there is that you must have a great circle going through the center of that circle. So I can't just make my slice anywhere. It's got to go through the center of it. The circumference of the great circle is also the circumference of the sphere. And then also a great circle divides the sphere into what we call 2 hemispheres. Oops. So there's your vocabulary. Make sure you've got those pictures too. The pictures are really helpful. All right, next thing you need to know is the formula for the surface area of a sphere. Given any sphere, my surface area is going to be 4 pi r squared. So let's look at some examples. I'm going to find the surface area of my sphere, and I'm going to leave it in terms of pi. So in this first example, I need to first recognize my formula is 4 pi r squared. I need to find my radius. I don't have my radius here. They gave me my diameter. But if I cut that in half, I know that my radius is 5 meters. So that gives me 4 pi times 25 meters squared, which gives me 100 pi meters squared is the volume of my sphere. So you go ahead, you try that next problem. The next thing we have to do is we're going to look for the surface area of the sphere. However, we're given different information, not the exact information that we need. So a hint to you is that you need to find your radius somehow. In this first example, the Earth's equator is about 24,902 miles long. What is the approximate surface area of the Earth rounded to the nearest 10,000 square miles? So that's important. The other thing is that the Earth's equator is 24,902 miles long. My equator. So think about the equator of the Earth. The equator of the Earth is the circumference of my sphere. It's the line in which I'm able to cut my sphere into 2 equal halves or hemispheres. So I know circumference is 2 pi r. And I know that in this case, my circumference is 24,902 miles. So what I need to do is I need to take that value and I need to divide it by 2 pi so that I can get my radius. So 24,902 divided by 2 pi. My answer is 12,451 pi miles. That's my radius, which is helpful to me, but it's not everything, okay, because now I need to plug it back in to my formula for volume, which was 4 pi r squared. So I get volume equals 4 pi. My radius is 1 pi, and I need to square that. Sorry, I kind of ran out of space there. So I'm going to square that value, multiply by 4 pi. Wow, that is a really big number. So your calculator is going to give you scientific notation, but they want us to round to the nearest 1,000 square miles. So we actually have to figure this out. Let's see. Let me change to a different color. So the answer I got is 1.922728995 times 10 to the 10th. So I'm going to move that out of scientific notation form. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a 0 there at the end when I move that decimal place. They want us to round it to the nearest 1,000 square miles. So my answer is going to be 19227290000. So I had to take this value that my calculator gave to me. It was in scientific notation. So I have to move my decimal place 10 spaces in order to get it out of scientific notation, be my really big number answer. Then I need to round it up to the thousandths. Now, this is my thousandth spot, which means I need to round this 9 up because the 5 next to it. But this is also a 9. So I just need to round this whole thing, this to a 9, 0, 0, 0, 0. So that's where I get my answer from. My volume right there, and I have miles cubed. You try that next problem. It's going to be a lot smaller of an answer because you're dealing with a cantaloupe, so you shouldn't have the issue with having to convert from scientific notation into your actual answer. The next thing we're going to talk about is the volume of a sphere. For volume of a sphere, my formula is V equals 4/3 pi r cubed. So let's look at these examples. Okay, I'm looking for the volume in terms of pi. So I have V equals 4/3 pi r cubed. They told me that my radius is 6 meters. So I'm going to plug that in and I'm going to cube it. 6 cubed is 216. But remember, we need to multiply that by 4/3 and by pi. So my answer ends up being volume equals 288 pi meters cubed. Then you go ahead and try that next problem. So this next thing we have to do is we have to use our volume in order to find our surface area. Now my hint to you is that you should always find your radius using your volume. Once you have that radius, then you can go ahead and plug it into your surface area formula. So let's take a look at this first example. My volume, remember, we know is 4/3 pi r cubed. But in this case, they told me that my volume is 5,000 meters cubed. So I'm going to set that equal to my formula. Now, after I have it set equal to my formula, my goal, of course, is to get my radius by itself. So in order to do that, I have to eliminate a few things. First of all, this pi. I need to get rid of pi. So I need to divide by pi. But I also, before I do that, want to get rid of my 4/3 fraction. To get rid of my 4/3 fraction, I'm going to multiply by both sides, on both sides, by 3/4. That's my reciprocal. And when I do that, they're going to cancel out and go to 1. So my 4/3 is gone. And then I have 5,000 times 3/4. Can stick that in my calculator. And I get 3,750 meters cubed equals pi r cubed. Now remember, we said we have to divide that pi out. Let's do that right now. So I get r cubed equals 1193.662073. Remember, you don't want to round within a problem because it can make your answer less accurate. All right, so now I need to take the cubed root. Because right now I have r cubed, I don't want that. So I'm going to take the cubed root of both sides. So I'm going to put that into my calculator, and this is a little bit harder to do. What you have to do is hit the second button, and then your caret button. Right above that caret button, you see a little x radical. So you are going to hit the number 3 because that's the route you want to take. The second button, your caret button, which puts it into a cubed root form. Then you're going to type in that whole number, 1193.662073, enter. It gives you that your radius is approximately 10 point, let's carry out that whole decimal, 607844418. That's my radius. So we're almost done. If we're looking for the surface area, we now just have to plug that in. So surface area equals 4 pi r squared. So 4 pi times my radius, that whole decimal, squared. So let's square that thing in our calculator. And then I'm going to multiply it by 4 pi. In my answer, it does say what is the surface area to the nearest square meter. So let's write our answer, then we'll round it. We get 1414.04792. So to the nearest square meter, 1414 square meters. Surface area is 1,414 square meters. So it is a lot of work because you essentially have to go through and do 2 problems. You're first looking at your volume, which they've given you. You have to go through and you have to solve for your radius. That takes a little while. Once you get your radius, then you can plug it into your surface area formula and then just make sure you're rounding properly. So here's a U-Try problem for you. Make sure that's in your notes. Make sure you really put full effort into this. It is going to be a more difficult problem, but I know that you are capable of doing it. See you in class.